Okay guys, we're going to learn how to find the molar mass of a substance. These are our Cornell notes that you can fill out your name, class, period, and date right here. Their topic is molar mass, and our essential question is how do you find the molar mass of an element or a compound? Now, what you need to know, I'm going to focus this here so it doesn't go in. There we go. Okay. What you need to know when you are finding the molar mass is whether or not it's an element or compound. How do you tell what you're going to be looking up for? And what we're going to start with is what in the world is the molar mass? And the molar mass is a number. It is the mass in grams of 1 mole of a substance. So if I have a mole of something, remember a mole is 6.02 times 10 to the 23rd particles. So if I have 6.02 times 10 to the 23rd particles, I have a mole and it will have some particular mass. And the units that we use are grams per mole. Now if I want to find the molar mass, I need to know if it's an element or a compound because it's pretty easy if it's an element. So if it's an element, first off, you'll know it's an element because it only have one capital letter. If it has one capital letter, like Fe or anything on the periodic table, then it's an element. And those are pretty easy. All you have to do is look it up in the periodic table. In the periodic table. So here's a periodic table. All these numbers in here, these numbers down here, it says average atomic weight, average atomic mass sometimes. That is the molar mass. So that tells you how many grams 1 mole of the substance has. So sometimes some of the elements have are a molecule, like O2 for oxygen. Then you just have to add up how many there are. So let's look at some examples. For example 1, let's find the molar mass of zinc, Zn. So what I have to do is find zinc on the periodic table, Zn. There it is. Maybe you can't read that number from the video, but if I zoom in some, it says 65.38, and then there's a parentheses 2. So 65.38. The 2 is just a less accurate digit, so we'll just leave that one off, and then it's grams per mole. That's it. That's how you find the molar mass of zinc. So let's look at one where it is a molecule. Iodine comes in a molecule. It's I2. So what I have to do to find that one is I have to find iodine. There it is. I would be 126.90. But since I have 2 of them, then I need to have 2 in my calculation. So I'm going to use my handy calculator here, 126.90 times 2, and I get 253.8. So the molar mass of iodine is 253.8 grams per mole. This is actually how it's going to work when we calculate the molar mass of a compound. So let's flip over to the back side here to have things a little organized to find molar mass of a compound. And these are the ones that can get tricky. The gist of it is, though, you have to add up all the parts. That's hard when you've got the parentheses and all those little subscripts, and what are those going to look like? So we'll just do some examples here together. So for our first example, we'll do carbon monoxide. Carbon monoxide is CO. So we're going to find C and O in our periodic table. C is 12.011 and O is 15.999. Now I just have one of each of those, no subscripts, so all I have to do is add those numbers up. 12.011 plus 15.999, and I get 28.01 grams per mole, and that's my answer. Okay, so I'm just adding up those pieces. Let's look at another example, one that's a little bit harder. How about lithium sulfide? Lithium sulfide is Li2S. Li and S are what I'm going to need for this one. Li is on this side of the periodic table, 6.94 S is over here, and it is 32.0, I think that's a 6. So I have 2 of this one here, so I'm going to have to do a little bit of math. I've only got 1 of the sulfur, so that's the 32.06. 6.94 times 2 is 13.88. So now I have my pieces, and I have to add them up. It's 13.88 plus, oops, 13.88 plus 32.06, and I get 45.94 grams per mole. So when you have pieces, more than one piece, then you'll just add them up together, and then you're adding all the pieces. Just make sure you do any multiplying first and then add second. Sometimes the calculator won't do it the right way. So now let's look at one of those really complicated ones. Let's look at zinc nitrate. So, and zinc 2 nitrate. Okay, so that's going to be Zn, and then nitrate is NO3, and then we need 2 of those. So this one is one of those complicated ones. If you get stuck on this, try to draw a particle diagram. That'll be 1 zinc, let's see, 1 N and 3 O's, but then I need 2 of that set. So I can see here I'll need 1 zinc, 2 nitrogens, and 6 oxygens. Another way you could think about that is this 2 distributes, but we're not adding, we're multiplying. So what I'll write down is zinc, nitrogen, and oxygen. Let me look those guys up in my table here. Zinc is 65.38, nitrogen is 14.007, and oxygen is 15.999. I only have 1 of the zincs, so 65.38. My 2 distributed, so I need 2 of those oxygens, or I'm sorry, nitrogen, so 14.007 times 2, so 28.014. And then for the oxygen, I need 3 of those in here, and I need 2 of that whole set. So I'm going to multiply by both 2 and 3, or I'm going to multiply by 6. Remember, I drew those out, 1, 2, 3, 4, 5, 6 of them, 2 times 3. So 15.999 times 6 gets me 95.994. And then I have to add everything up again. Same idea, always adding up the pieces. 95.994 plus 28.014 plus 65.38, and I get 189.388 grams per mole. And that's it. That's all you have to do. Writing a summary of what you did to find the molar mass of a compound and what you did to find the molar mass of an element will help you out when you are thinking about molar mass. Now, go work on the homework.